Breastfeeding is best, so you're doing it. You've ensured that you don't do anything to jeopardize the process. But despite your commitment, you've run into difficulties. The difficulty? There just doesn't seem to be enough breast milk to keep baby satisfied. How come? Researchers from the Cincinnati Children's Hospital Medical Center have begun to piece together the mystery of why some women don't have enough breast milk by analyzing which genes are involved in getting milk to flow. Join us for this episode of Better Body Chemistry TV as we discover just what it takes to get milk flowing. Better Body Chemistry TV is brought to you by Dr. Sandy, a scientist turned gremlin buster, helping you battle sugar gremlins, heifer lumps, and other health horribles through Better Body Chemistry. Remember, small things can make a big difference to your health. Now, transforming breasts from an attractive appendage to a fully functional milk factory is a process, and several hormones are involved in the development. Prolactin is the chief engineer. She kicks off the process with some serious remodeling because the breast must first and foremost be very grabbable so that baby is able to latch on and tuck in. And next, big enough to keep baby fully supplied. During the course of pregnancy, the necessary adjustments are made. The nipple and areola become larger, the ducts and the alveoli are extended, and the blood supply is enhanced. But it's not just enough to have the machinery in place. The mammary gland has to step up production processes so that it can produce large quantities of breast milk. It seems prolactin subcontracts this job. Now, the very first drops of milk, the colostrum, are rather special. Their release is orchestrated by oxytocin, the hormone in charge of labor. You see, the uterus is not the only tissue sensitive to oxytocin's messaging. The myoepithelial cells in the breast tissue also get pushing. The first drops of milk quite literally leak out, squeezing through the not so tight junctions which separate the breast epithelial cells from each other. But moving the milk between cells is inherently inefficient and definitely not sustainable. So, as the machine comes fully online, the milk is actively secreted in an energy-intensive process. Typically takes a few days to get the milk production machine fully functional. For most women, this happens around day 4 or 5 postpartum. At this point in time, breast engorgement peaks. Mom and baby slip into a rhythm where production perfectly matches consumption. For years, scientists have wanted to peek inside the factory to learn more about who is involved in the process and what goes wrong when the machine fails to come online properly. Unfortunately, this was impossible to do. No mom in her right mind would allow scientists to chop out bits of a breast tissue to study gene expression. But technology has come to the rescue. The Cincinnati team were able to spy on what was happening inside the human milk factory using RNA sequencing. You see, the mammary epithelial cells who are doing the work use RNA sequences to guide their production decisions. And, well, some of these RNA molecules end up in the milk. Now, they don't last very long, but if the scientists are quick, they can catch enough of them in a fresh milk sample to get a really good picture of what is going on. The team discovered a staggering number of genes are involved in the process. In total, it takes 8,817 genes to get the milk machine from drooling out colostrum to real milk. But different genes are involved along the way. The team identified 3 distinct phases. Phase 1, which was the colostrum, involved the expression of genes that are important for immune defenses. The proteins being produced during this phase included isoferritins and cathepsins. Phase 2, which is the transitional phase, involves the expression of genes that are setting up the production process, specifically genes that are part of the protein synthesis machinery. And phase 3, the mature stage, it's all about feeding baby. 2 foodie proteins dominate this phase, beta-casein and alpha-lactalbumin. Alongside these foodie proteins, many genes involved in lipid synthesis also come online. Interestingly, the team found women transition through these phases at different speeds. So day 3 milk in mom number 1 might be a little different from day 3 milk in mom number 2. This means many moms who are battling to breastfeed might be calling it quits too early. The floodgates only open when you hit phase 3. The absence of copious amounts of milk is because the factory is a little slow coming online. It's a delay, not a failure. The milk is still coming. The team discovered that many of the genes being upregulated were taking their cue from insulin. And when production troubles arose, insulin resistance was implicated. Women who were insulin resistant were slower to fill up. Insulin sensitive women hit peak engorgement at 34 hours, while insulin resistant women peaked at around 72 hours. Insulin resistant women also had more trouble keeping the milk production going. Genetically speaking, moms who were insulin resistant had altered expression of a specific gene, the PTPRF gene, during phase 3 of milk production. PTPRF, I know, it's like alphabet soup. The PTPRF gene makes an enzyme known as the protein tyrosine phosphatase enzyme, and its job is to remove a phosphate group from the amino acid tyrosine. So what? Well, it turns out that this little enzyme is actually a key player in insulin resistance. The presence or absence of the phosphate group impacts how responsive a cell is to insulin. And insulin is a bit of a bully, it seems, in women who are insulin resistant. The enzyme is working overtime in the breast tissue. It's trying to keep things in balance, compensating for excess insulin. So to keep the lights on in the factory, it seems it is necessary to rein in insulin. This is not that hard to do. Little tweaks in your diet and lifestyle can improve insulin sensitivity. All that it needs is a little candy flossing. Need a little help? Download our special free report available at www.betterbodychemistry.com and begin the journey to better body chemistry and better health. The advice is simple to follow and based on real science, not hype. Know someone who wants to breastfeed? Share this video with them so they understand how to get the milk factory to come online and stay online. And if you enjoyed the video, be sure to subscribe to our channel so you catch future episodes of Better Body Chemistry TV. Thank you so much for watching, and I'll see you next time. Remember, small things can make a big difference to your health.